Welcome back. So far in this series, we've been writing Terraform code and deploying infrastructure to AWS. But have you ever wondered how Terraform remembers everything it created? How does it know which EC2 instance belongs to your project? How does it detect changes without recreating everything? The answer is the Terraform State file. Every time we run Terraform apply, Terraform compares our code with the state file, and then with AWS. That's how it knows exactly what needs to be created, updated, or destroyed. Today, we'll finally understand one of the most important concepts in Terraform. And, just like the previous episodes, we'll spend most of our time doing everything hands-on. At first glance, the state file may seem like just another file inside the project. In reality, it's the database Terraform uses to keep track of your infrastructure. It stores information about every resource Terraform manages. Before generating a plan, Terraform reads this file to understand the current state of your infrastructure. Then it compares that information with your code and with the real infrastructure running in AWS. Without the state file, Terraform wouldn't know what it created previously. It couldn't calculate changes efficiently, detect infrastructure drift, or determine what should be updated. That's why understanding the state file is essential before building larger production environments. As always, we'll begin with the official Terraform documentation. Then we'll inspect the state file generated by our previous projects. We'll learn how to read it and understand what information Terraform stores internally. Next, we'll intentionally modify our infrastructure outside Terraform so we can see how drift detection works. After that, we'll import an existing AWS resource into our Terraform state. And finally, we'll use AI to help us understand the output while validating every step against the official documentation. Almost everything you'll see today happens inside the terminal, VS Code, and the AWS console. Let's jump into the hands-on section. We'll continue using the same project we've been building throughout this series. We already have resources deployed, which makes it the perfect environment to understand how Terraform State actually works. Before writing any new code, let's open the official Terraform documentation and see how HashiCorp defines state. Then we'll come back and inspect the real state file generated by our own project. Right away, HashiCorp tells us that Terraform uses state to keep track of the infrastructure it manages. It maps our Terraform configuration to the real resources running in AWS and uses that information to calculate every execution plan. As we look through the navigation menu, we can see there are many topics related to state. We have the general overview, the purpose of the state file, remote backends, refactoring state, removing resources from state, state locking, workspaces, and remote state. These are all important topics, but trying to cover everything in one episode would make it overwhelming. So today, we'll focus on the fundamentals. We'll understand what the state file is, inspect its contents, see how Terraform uses it to track infrastructure, detect configuration drift, and finally import an existing AWS resource into Terraform. The more advanced topics, such as remote backends, state locking, and workspaces, will naturally appear later in the series as our projects become more production ready. With that overview in mind, let's go back to our project and inspect the actual terraform.tfstate file that Terraform has been maintaining for us since the beginning of this series. Terraform tells us that the current state file is empty. This is expected because we destroyed the infrastructure at the end of the previous episode. After Terraform deleted the resources, it also updated the state file to reflect that nothing is currently being managed. The state file is not a history of everything Terraform has ever created. It represents Terraform's current view of the infrastructure. However, Terraform also created a backup of the previous state. This backup contains a state from before the destroy operation. At first glance, it looks like a huge JSON document, but don't worry, we're not going to read every line. Instead, let's understand its structure. At the very top, we can see some metadata. We have the Terraform version that generated this state, a serial number that increases every time the state changes, and a unique lineage identifier for this infrastructure. Next, we have the output section. These are exactly the outputs we defined in our Terraform configuration. Terraform stores their latest values here so they can be displayed every time we run Terraform output. We can see our VPC ID, our security group ID, the Amazon Linux AMI, and the IDs and private IP addresses of both EC2 instances. This is the most important section of the entire file. The resources section. Every resource managed by Terraform is recorded here. Here are our EC2 instances. Notice something interesting. Because we used for each in the previous episode, Terraform stores two different instances, one called API and another called Web. If we expand one of them, we can see almost everything Terraform knows about this EC2 instance. The instance ID, the AMI, the instance type, the public IP, the private IP, the subnet, the security groups, the tags, and many other attributes. Terraform doesn't query AWS every time it needs this information. It stores the current known state locally, making planning operations much faster. The same happens with our security group. Terraform stores its ID, its rules, the VPC where it belongs, and every attribute needed to compare our code with the real infrastructure. So this file is much more than a simple JSON document. It's Terraform's memory. It represents everything Terraform currently believes exists in our infrastructure, and that becomes extremely important when something changes outside Terraform, because that's exactly how Terraform detects infrastructure drift. This backup is useful for recovery and comparison, but it is not the active state Terraform is using right now. The active state is empty because the real infrastructure was destroyed. Now let's recreate the infrastructure so we can inspect an active state file that matches real AWS resources. Terraform will recreate the resources defined in our configuration. Once the apply is complete, Terraform will update the active state file with the new resource IDs and attributes. The infrastructure has been created again. Let's run Terraform show one more time. This time, Terraform displays the resources it is actively managing. We can see the EC2 instances, the security group, the rules, the data sources, and their current attributes. This output is a readable representation of the active terraform.tfstate file. Terraform state list command gives us a compact list of every address currently stored in the state. Notice that the EC2 instances are identified by there for each keys, by your API and web. Now, the active terraform.tfstate file contains the newly created infrastructure. The values may be different from the backup because AWS generated new instance IDs, IP addresses, network interfaces, and volumes. The important point is that the active state now matches the infrastructure currently running in AWS. Now that the state and AWS are synchronized again, we're ready for the next experiment. We'll change something directly in the AWS console and see how Terraform detects infrastructure drift. Until now, every infrastructure change has been made through Terraform. Now let's simulate something that happens very often in real environments. Imagine someone logs into the AWS console and modifies a resource manually instead of using infrastructure as code. I'll change the EC2 instance type directly in AWS. Notice that Terraform doesn't know anything about this change yet. Terraform compared three things: our Terraform configuration, the current state, and the real infrastructure running in AWS. It immediately detected that the EC2 instance no longer matches our configuration. This difference is called infrastructure drift. Someone changed the infrastructure outside Terraform, and Terraform is telling us exactly how to bring it back to the desired state. At this point, Terraform gives us a choice. We can accept the manual change by updating our code, or we can enforce the desired configuration defined in Terraform. In this case, infrastructure as code remains our source of truth. So we'll apply the plan and let Terraform restore the infrastructure to the configuration defined in our project. The apply completed successfully. Our infrastructure is now back in sync with the Terraform configuration. If we run another Terraform plan, Terraform should report no changes, confirming that our configuration, the state file, and the AWS infrastructure are once again aligned. Now that we've seen how Terraform detects and fixes infrastructure drift, let's look at another powerful state feature: importing existing resources into Terraform without recreating them. Let's quickly look at the official documentation. Terraform provides an import command that associates an existing resource with a resource block in our configuration. Notice something important. Import does not create infrastructure. It only tells Terraform, this resource already exists. Start managing it. Let's do a quick hands-on test. We'll create an EC2 instance manually in AWS outside of Terraform. This is important because we want to simulate a real-world scenario where infrastructure already exists before Terraform starts managing it. Let's go to the AWS console, open EC2, then go to Instances and click Launch Instances. For the name, let's use terraform-import-demo. For the AMI, I'll choose Ubuntu. For the instance type, we'll keep it simple and use t3.micro. For the key pair, we don't actually need to connect to this instance for today's demo, so we can continue without creating a new key pair. For the network settings, we'll keep the default VPC and use the existing security group from our Terraform project so the networking stays simple. Then we'll launch the instance. Now, this EC2 instance exists in AWS, but Terraform has no idea that it exists. If we run Terraform State list, this instance will not appear because Terraform is not managing it yet. Before we continue, I just noticed something that I'd like to fix. Our resource is currently named Ubuntu_server. That name made sense when we were experimenting with Ubuntu earlier in the course. However, if you look at our Terraform configuration now, we're no longer deploying Ubuntu. We're using Amazon Linux. Since resource names should clearly describe what they represent, this is a good opportunity to rename it before we move forward. Instead of Ubuntu_server, let's rename it to something more accurate, like Linux_server. This doesn't change anything in AWS. Remember, the resource name is only Terraform's internal identifier. It's how Terraform refers to the resource inside our configuration and state. Interesting. We changed only the Terraform resource name, but look at the plan. Terraform wants to destroy our 2 existing instances and create 2 new ones. Why? Because Terraform doesn't identify resources by their AWS name tag. It identifies them by their resource address in the state. Our state still knows these instances as Ubuntu_server, but our configuration now calls them Linux_server, so Terraform thinks the old resources were removed and completely new resources were added. We definitely don't want to destroy working infrastructure just because we renamed something in our code, and this gives us a perfect opportunity to learn another state operation, moving a resource inside the Terraform state. The Terraform State MV command does not change anything in AWS. We're simply telling Terraform, the resource you previously knew as Ubuntu_server API is now called Linux_server API. The real EC2 instance stays exactly where it is. We're only updating its address inside Terraform State. Much better. Terraform now understands that these are the same EC2 instances with a new resource address. We changed the Terraform code and updated the state without destroying or recreating any infrastructure. This is why understanding Terraform State is so important. A simple refactor in your code can become a destructive infrastructure operation if the state isn't updated correctly. Now that our existing state is clean and our resource names are correct, Let's continue with our import example and bring the manually created Ubuntu instance under Terraform management. Before we import this EC2 instance, let's keep things simple. Instead of building the perfect Terraform configuration from the beginning, we're going to hardcode a few values first. Why? Because right now our goal is to understand how Terraform import works, not to build the most reusable or production-ready code. So we'll start with a simple configuration that matches the EC2 instance we created manually. Once we confirm that the import works correctly, we'll come back and improve this code using the best practices we've learned throughout this course. We'll replace hard-coded values with data sources, variables, locals, and other Terraform features to make the configuration cleaner, more reusable, and easier to maintain. This is actually how many real projects evolve. You don't always start with the perfect configuration. First, you make it work, then you improve it. Let's create the resource block. Let's go through it line by line. First, we define an AWS underscore instance resource named Ubuntu underscore server. Remember that this is only Terraform's local resource name. It doesn't have to match the EC2 instance name in AWS. Next, we specify the AMI. For now, we're hard-coding the Ubuntu AMI that we used when creating the instance manually. Later, we'll replace this with a data source, so Terraform can automatically retrieve the latest Ubuntu AMI instead of relying on a fixed ID. Then we define the instance type. Again, we're hard-coding it for now because we want our configuration to match the existing EC2 instance exactly. Next, we associate the instance with the security group that Terraform is already managing. This part doesn't need to be hard-coded because we already have that resource under Terraform management. Finally, we add the name tag. This should match the tag we assigned when creating the instance manually in the AWS console. At this point, our configuration represents the existing EC2 instance. Terraform has a resource block. AWS has a real EC2 instance. The only thing missing is telling Terraform that both refer to the same resource, and that's exactly what the Terraform import command will do next. Now we have both pieces in place. We have the EC2 instance that already exists in AWS, and we have a resource block in our Terraform configuration that will represent that instance. One small adjustment before we continue. Since we already renamed our existing Terraform instances to Linux underscore server, I don't want to reuse that resource name for this import demo. Let's give the imported instance its own clear Terraform address. Now let's go back to the AWS console and copy the instance ID of the EC2 instance we created manually. Now we can run the import command. Let's break this command down. First, we have Terraform import. This tells Terraform that we want to associate an existing infrastructure resource with our Terraform state. Next, -var. Our project uses variables, so we provide the same development variables Terraform needs to evaluate the rest of the configuration. Then we have AWS underscore instance dot import underscore demo underscore instance. This is the Terraform resource address. It identifies the resource block we just created in our configuration. And finally, the instance ID. This is the actual EC2 instance ID from AWS. So in simple terms, we're telling Terraform, this EC2 instance that already exists in AWS belongs to this resource block in my Terraform configuration. Let's run it. When you get import successful, say the import completed successfully. And notice something important. Terraform did not create another EC2 instance. It did not restart this instance. It did not replace anything. It simply read the existing resource from AWS and added the relationship to Terraform State. Let's prove that. First, let's list everything Terraform is currently tracking. We can see our existing resources, our Linux underscore server instances, our security group, and now we also have import underscore demo underscore instance. We can inspect it in more detail with Terraform State show. Now Terraform shows us everything it learned from AWS. the AMI, the instance type, the subnet, the private and public IP addresses, the security group, the tags, and many other attributes. But there's one very important thing we still need to check. Importing a resource into state does not guarantee that our Terraform configuration perfectly matches the real resource. Remember, we intentionally started with a very simple, partially hard-coded configuration. So now let's ask Terraform to compare our code with the infrastructure Terraform plan. And this is where Terraform import becomes really interesting. If our configuration doesn't match the existing EC2 instance, Terraform will show us the differences. It may propose changing tags, network settings, or other attributes. And if we configured something like a different AMI, Terraform could even propose replacing the instance. So after an import, we should never immediately run Terraform apply. First, we inspect the plan, then we update our Terraform configuration until it accurately represents the infrastructure we actually want to manage. Once that works, we'll improve this hard-coded resource using the Terraform features we've already learned throughout the course. Perfect. This is exactly what we wanted to see. Terraform successfully imported the existing EC2 instance into the state, and now our configuration matches the real infrastructure. When we run Terraform plan, Terraform reports no changes. That means three things are now aligned: our Terraform configuration, our Terraform state, and the real EC2 instance running in AWS. You might join a company where infrastructure already exists, and instead of destroying and recreating everything, you can gradually bring those existing resources under Terraform management. Now that we've seen how to add an existing resource to state, let's look at the opposite operation. What happens if we want Terraform to stop managing a resource without actually deleting it from AWS? That's where Terraform State RM comes in. Our imported instance is currently tracked by Terraform, but sometimes you may want Terraform to stop managing a resource while keeping the actual infrastructure running. Maybe another team is taking ownership of it. Maybe you're moving the resource to another Terraform project, or maybe you're restructuring your infrastructure code. Terraform provides a state command for this, Terraform State RM. And there's an important distinction here. This command removes the resource from Terraform State. It does not delete the actual EC2 instance from AWS. The resource has disappeared from Terraform State. The EC2 instance is still running. Nothing was destroyed. We only removed Terraform's knowledge of that resource. This is why state commands are powerful, but also dangerous. We're directly changing Terraform's record of what it manages. Let's run plan again, and look at what happens now. The EC2 instance still exists in AWS. The resource block still exists in our Terraform configuration, but we removed the relationship from the state. Terraform no longer knows that the existing EC2 instance belongs to this resource block. So, from Terraform's perspective, the configuration says, I need an EC2 instance, but the state says, I don't have one. That's why Terraform now wants to create a new instance. This is a perfect example of why Terraform State is so important. Terraform doesn't simply look at AWS and automatically adopt resources. The state defines the relationship between your configuration and the real infrastructure. So how do we fix this? The EC2 instance is still running in AWS. Our Terraform configuration still defines the resource. The only thing missing is the relationship inside Terraform State. So the solution is simple. We import the existing EC2 instance again. Perfect. We're back to no changes. Your infrastructure matches the configuration. This is exactly what we wanted. Terraform now knows that the EC2 instance already exists and that it belongs to this resource block. Nothing was recreated, nothing was destroyed. We only restored the relationship inside Terraform State. And this is the key lesson from this example. The configuration describes what we want. A WS contains the real infrastructure, but Terraform State is what connects those two worlds. If that relationship disappears, Terraform can make the wrong assumption and propose creating infrastructure that already exists. Now that the import is working, let's use AI for something more useful. Our current resource block works, but we intentionally started with hard-coded values. So instead of asking AI to create the infrastructure for us, we're going to ask it to review the working configuration and suggest improvements based on the Terraform concepts we've already learned. I'm going to give the AI our current resource block and ask, review this Terraform EC2 resource and suggest how to improve it using data sources, variables, locals, and reusable patterns. Do not change the behavior of the infrastructure. Explain each recommendation before showing any code. This is an important distinction. Terraform already works. The infrastructure already exists. We're not asking AI to guess how to build it. We're asking AI to help us refactor working code. That makes AI an accelerator, not the source of truth. And after reviewing the suggestions, we'll validate any changes with the official Terraform documentation and, of course, with Terraform plan. The AI suggested several good ideas. For example, replacing hard-coded values with variables, moving repeated values into locals, reusing our common tags, and making the resource more reusable. These are all good recommendations, and they align with Terraform best practices. However, I also want to be careful. Just because the AI suggests a change doesn't mean I should immediately accept it. Every recommendation should be reviewed, understood, and validated before becoming part of the project. For today's episode, I'm going to keep the example simple. I don't want to spend another 20 minutes refactoring code that uses concepts we've already covered earlier in this course. Instead, I'll make those improvements after recording this episode. So when we start the next chapter, this configuration will already be clean, reusable, and aligned with the Terraform best practices we've learned so far. That's how I personally use AI, not to replace my understanding, but to review my code and suggest improvements that I can validate before accepting. Let's quickly recap what we learned today. We started by understanding what the Terraform State file is and why it's one of the most important pieces of every Terraform project. We saw how Terraform uses the state to map our configuration to real infrastructure. We learned how to inspect the state, how to rename resources safely using Terraform State MV, how to import existing infrastructure with Terraform import, and how removing a resource from the state with Terraform State RM is completely different from deleting it in AWS. Most importantly, we saw that Terraform State is the bridge between our configuration and the real infrastructure. Understanding that relationship is what allows you to manage infrastructure safely and confidently. In the next episode, we're finally going to stop relying on the default AWS network. Instead, we'll build our own production-style AWS networking environment from scratch using Terraform. We'll create our own VPC, public and private subnets, internet gateway, route tables, security groups, and prepare the networking foundation that we'll use throughout the rest of this Terraform series. If you enjoyed this episode, don't forget to like the video, subscribe to the channel, and I'll see you in the next one. Happy learning, and see you next time.